Thanks. Good morning, folks. I feel like we all know each other. Kelly, did you get to meet everybody before? Do you want to do intros?
Sure.
Okay. Stephanie Camino, the director of the Blackstone Watershed Collaborative.
Rachel Nibner here at DEM.
Kevin Rice, Finance and Program Manager for the Collective.
Just back to me, we're on DEM.
Matt Gendron, Fish and Wildlife.
Kelly Phelan, TNC on this project.
Kate McPherson, Save the Bay.
And Darcy.
Hey, good morning, everybody. Darcy Young, Narragansett Bay Estuary Program.
Thanks, Darcy. We probably will have a couple others joining at some point, but they can introduce themselves later. Apologize that I did not send out an agenda. We had the fish parade on Saturday and that stole my brain. And then it was only this morning that I was about to head here wondering, oh, what are we going to be talking about? And I said, oh, I don't know, because I didn't make an agenda. So it worked out that I heard Nils is kind of here and ready to present and share some information, so we can just start there.
Okay, great. Yeah, good morning, everybody. And we have been continuing to work on the development of the full dam removal concept. And we had a little bit of an update with Matt and Jay and Phil, just as an outline of where the progress is for that. And Sean Aruda is going to be joining in a minute here, and he'll kind of provide some of the graphics outlining the status of that design. And I think he may have noted that there was some model updates that were completed for the Roosevelt Avenue Bridge, where we went out and took some field measurements as to the channel inverts below the bridge deck, and updated the model for that. And then also, built in other sections through the spillway and the downstream bedrock falls, so to speak. And then we modeled essentially removal of the full constructed portion of the dam down to the bedrock ledge at which the dam is constructed. And we kind of started at that as the base point to see, from a minimalistic standpoint, how little can we do to achieve the fish passage, criteria in terms of safe, effective, and timely passage through the site. And as we looked at those results, again, just removing the spillway, leaving the bedrock, and leaving the channel upstream where it is, we saw that there were a number of both depths and velocity barriers downstream of the bridge, as well as through the falls itself. And when Sean's able to get on now, he'll show you where some of those pinch points were. So from that point, we started to introduce some weirs to reduce velocities and increase depths in those areas of concern. And we're really kind of just built up incrementally from there to see, starting downstream of the spillway, to address some of the depth and velocity barriers through the bedrock area, and then continuing up until we got to a point where there were no depth or velocity barriers at the bridge itself. And so at the end of it, we ended up with about eight weirs. And right now we've got some elevations and determined what, conceptual notch widths are. Obviously the notches will be split off so that there are many avenues for fish to migrate up through. But we also want to be cognizant of, downstream recreational opportunities. So that'll be something that's looked at in the next stage, if this is a preferred alternative. And then we are also looking at the geomorphic, characteristics of the river and how those would be affected. And Sean has run some analyses for flow depths under aquatic base flow conditions, which is your seasonal low flows in July to October, as well as what depths may be present during drought conditions, 7Q10 conditions, and obviously a reduction of channel depths upstream is going to correlate to a reduction of the channel width. And so again, we're recognizing that there's some exposed channel banks that would develop under a full dam removal that are currently inundated. We've, based upon our assessment of the channel bed upstream of Roosevelt Avenue, it's a lot of gravel and sand, not a lot of organics and cobbles. So we don't feel that there's going to be a significant volume of sediment that would potentially migrate downstream from there. But between the bridge and the dam, there's, a relatively appreciable volume of more fine sediment, particularly on the left or the northern bank downstream of the bridge. There's some eddy areas in there where sediments kind of accumulated, and we expect that there would be some, redistribution of that sediment. Obviously, there's the option to go in there and proactively remove it and shape it and try to, get it into a configuration that would be more stable and reduce the volume that would be migrated downstream. And obviously, the total volume and the rate at which it is distributed is a function of what storms occur and the magnitude of those storms and the proximity of those storms to the completion of work before the vegetative community is able to come in and encroach and stabilize those exposed channel bed areas. So that's part of the strategy for full dam removal, obviously, is to proactively deploy erosion controls, blanketing, seeding, plantings on those exposed channel bed areas that are now channel banks, and try to stabilize those so that you can get, a stable vegetative community that will kind of root into the sediment. But again, you never know when those 2-year storms that are going to come, and it might be a month after, completion of work, or it might be 2 years. And so that's part of the adaptive strategy for doing any kind of a dam removal, that you're concerned about sediment migration. So beyond the, and I'll kind of just end it here with like the big picture stuff that we've been working on is not only the reduction of the normal channel width and the flow depths during those aquatic base flow conditions, and obviously during the, spring flows, kind of normal conditions, if you will, throughout the significant portion of the year, is the stability of the channel banks between the bridge and the dam. So on the right-hand river right on the southern bank, there's a building. I don't know if it's a commercial building or a private building downstream of the bridge, and it's really proximate to the river. That whole bank area has some armoring in place to kind of provide some level of stabilization. But we haven't done, a complete investigation at this stage. I mean, it would be something that we'd look at in the next phase if this is a preferred alternative to say, what's the condition and, what's the sizing of that armor on that right bank, that southern bank, and is it adequate or would it need to be supplemented? So for purposes of kind of developing an opinion of cost, we're taking a conservative approach until we can determine that there is no action needed, and we're assuming that there will need to be some rehabilitation or reconstruction or replacement of that armor on the right bank between the hydro facility and the bridge. The left bank on the northern side of the river, most of that property is owned by the Pawtucket Redevelopment Authority. And until you get down closer to the dam, there are some residential properties. I can't remember the name of the street that extend partway down, but they don't go all the way down to the edge of the river. So our concern on the left bank is more the characteristics of the geologic soils and potentially weak soils that may be unstable with the river being lowered several feet lower than it is now. So there's kind of a transient condition where water is draining out of the slope, where, right after the dam is removed, where water that's standing in the slope is draining out, and it might carry soil particles with it, or might result in a kind of a transient instability. but then there's also a longer term potential instability, of course, as well as a bank erosion. So those are two things that we'd want to look at to assure that those properties, in the downstream portion, closer to the dam on the northern bank or west, I guess the eastern bank at that point around the corner, are not going to be impacted, and there may be need for some type of structural support system there, whether it's a sheeting system or a bulkhead system or some type of bioengineered system that we would be confident would be adequate for the loadings that it would be that it would experience in for the duration of time until we know that that bank is going to be stable. So again, and our continuing development of the opinion of cost for the full dam removal, we're looking at some stabilization practices on both banks, between the dam and the bridge itself. So right now we're kind of midstream in development of the content for the updated section. Right now we're mostly developing the graphics focused on these types of presentations, if you will, as to the status of the work. But we'll be incorporating those graphics into additional section, if you will, or additional pages of the tech memo. And then we'll have a short write-up of the geomorphic and the slope stability issues and concerns. And then obviously we will be getting into the matrix and fish passage benefits, O&M benefits, and other potential concerns with a full dam removal, including, of course, the sound curtain that the property owner is concerned about. And so we know that that's part of the conversation that will be happening over the next several weeks once our work is more complete. So I don't know, Jay or Matt, was there anything else that you feel came out of our prior discussion, or otherwise I can turn it over to Sean and Sean can provide a kind of an update?
Nothing, I think
Yeah.
you covered it, Nils. I think, people will be interested to see what Sean's
Yep.
about to show.
Okay. All right. So Sean, if you don't mind, go ahead and put up on screen and just talk through where we are right now.
Okay. So everybody sees that on their screen now. It's kind of a graph. All right. So really, this is just kind of a snapshot of kind of the additional sections that we have incorporated into our HEC-RAS model to kind of, again, improve the accuracy. Now that, exploring a full removal, channel bathymetry becomes all that much more important. So some of these sections you can see in green were added to the model from, I would say the last time where we left off with our previous analysis. I think the other thing also is some of probably the most important takeaway is these two sections here in blue. We updated those sections from FEMA's bathymetry. So, obviously this model was generated initially from what FEMA's model currently included. So what we did though is Katie and I went out there in March and we actually did, essentially we did, I'll say measurements from the bridge deck on both the upstream and downstream side where we were able to kind of, I would say, approximate pretty well the bathymetry at the bridge location. With more accuracy, obviously, than what FEMA has, and what we found was that there is actually more depth. So the channel bottom was deeper than what FEMA's model was currently showing. So what that means is that we have more flow area going through Roosevelt Ave than what we had initially anticipated. That reflects on better flow velocities because if you can recall, one of our concerns with dropping the dam too low was that we start to create a velocity barrier for fish passage. So now that we have more flow area going through there, that actually allows better velocities or results in better flow velocities. And, so I would say if I had to based on what I'm seeing, like if you recall before, we were kind of like, okay, if we start to lower the dam by more than 2.75 feet, then we do start to see some potential velocity barriers for fish passage. Now what I'm seeing is you probably could lower that dam by 5 feet and still have better fish passage velocities. So I would see that. I'm saying that I don't see the Roosevelt Bridge being as much of a velocity barrier anymore now that we got that bathymetry. So that's kind of what the overall takeaway from our existing conditions analysis showed. So let me just try and see if I can get this back here. Here we go. So also one of the things we wanted to do was better identify where we thought natural ledge was, because again, it's stated that the dam was built at a natural falls location. You can see the spillway elevation's about 34. And what we went out there, obviously we're unable to get in the river there because just the flows were too much, unsafe. So we were able to kind of roughly approximate, measure down from the timber, I'll say, overlook that exists there on River Right, and kind of measure down to see where natural ledge was approximately at. And we determined that to be about an elevation 25. So again, that's about 9 feet lower than the crest of the existing spillway. So the model was also updated to reflect that. This is, and I'm not going to get into this in any detail because there's just a whole bunch of measurements, but this is essentially the results of what Katie and I had measured. Our measurements are shown in blue. Essentially what we did is we kind of just went along the upstream and downstream sections every 10 or so feet, and we took channel bottom depths to kind of get somewhat of I'll say a channel bottom section profile in these locations. And so our values were a little bit different than what we found from the 77 bridge plans. Obviously the datums were different as well. So, we did adjust those accordingly. But overall, our actual channel bottom depths measurements weren't that different from what the 1977 Ride-Up Bridge plan showed. So we felt somewhat relatively comfortable. Obviously, we're not surveyors, but with that being said, we had some pretty good confidence that what we actually recorded out there from our measurements was, I don't know, relatively accurate. Okay, so this is basically this what this profile shows is the existing channel bottom. You can see the dotted line, which is what FEMA had reflected in their model. And now you can see this red channel bottom line is what we actually measured the channel bottom to be. So kind of like I was saying, you can see that there's actually more depth of flow going underneath the bridge, which is a good thing in terms of taking the dam out and the bridge not really becoming as much of a velocity barrier as we had initially thought. So the first thing that we did is we said, okay, we have this new channel bottom. We updated our model. Let's just wipe out the dam, right? Let's just take the dam out and let's see what that does. So some of the things, or a few of the things that we found is that you see this, we'll say 320-foot section of the river. This is where the existing dam was. That's the remaining natural falls location. We were able to say, okay, during the upstream migration season, again, I think we talked about this a few times in the past. Like generally, that's what we look. That's what everybody looks at when they're assessing upstream migration, or what we call these 95% exceedance to 5% exceedance flows. So basically, that's just the lower flows that you expect to see during the upstream migration season, and then the higher flows. So as long as you can design your fish passage or assess fish passage during those conditions, then pretty much you're capturing if you can make your fishway conducive to passage during that range of flows, then ideally that's you should be good. So what we did find is that we did have some depth concerns. Obviously, there was still going to be about a 2-foot hydraulic drop during the lower flow conditions during the upstream migration season at the existing natural falls location. So, clearly, the fish that we're dealing with do not jump. So that's the first, we'll say, vertical barrier. But then as you're kind of going through, there are a couple locations where you see the channel depths are less than about 1.5 feet. And 1.5 feet is kind of what we were using as a target. American shad has a body depth of about 9 inches, based on design guidelines that we use, U.S. Fish and Wildlife, NOAA. So what you're trying to do is you try and make sure that you can at least get 2 times the body depth of your largest species, which again, 0.75, 9 inches times 2 is 18 inches, 1.5 feet. So what we found were a few locations where the depths were less than 1.5 feet. So those are kind of shown here, 1.34 feet. It was a 0.93 foot depth. And then you had a 1.41 foot, which is pretty close, right, to 1.5. The other thing that we're looking at is simply just looking at the burst speed. What's the maximum burst speed of the target species? And we know that shad can have higher burst speeds than alewife or river herring. River herring have a burst speed of 6.25 feet per second. So that's where we then look to see, do we have any conditions where the flow velocities exceed the burst speeds of the target species? And yeah, you can see that there's 8.42, 8.18, 7.21. These were a little bit higher, not bad, 654, 668 feet per second. So the takeaway is that just taking the dam out and not doing any in-river improvements, you're likely going to have a few depth barriers and then velocity barriers in that location for suitable passage. We kind of just looked upstream too. Obviously, we want to see what, how do the hydraulics look in the river, excuse me, upstream of the Roosevelt Bridge. Um, not too bad in terms of velocities during the fish passage season. There were a few locations where the post removal velocities did increase, resulting in new locations that would exceed the cruising speed of the target species, but not the burst speed. So as long as though there are portions within that section of the river upstream that have some slower moving velocity zones, they still should be okay for passage. So I think the main thing that we found out is just that section of the river between Roosevelt Bridge and the dam is where we needed to focus on. So this is really just again, this is, we'll say, conceptual level. But what we did is we went through there and essentially we took the dam out and we put in a full river with nature lake fish in there, which consists of a series of step pools. So you have the stone boulder weirs, and then you have the pools that are in between. So kind of similar, I have a graphic here on the bottom left kind of showing what we did at Bradford. So it would kind of be the same sort of idea in this location. And you can also see I do have a portage path shown. So what that does is we actually threw a portage path essentially in the bypass channel alignment. So, again, it's just like at concept level, we still would keep this upstream portage, floating portage. That may have to be relocated a little bit now that we're going to drop water levels. So we may need to push that out a little bit into the river. And then once they get up on here, then they can just take this portage path down and plop right in downstream of the lowest nature lake barrier. Or nature like boulder weir into this pool area. So this was designed essentially to limit our hydraulic drops during all our upstream migration flow periods to 9 inches or less. Right now, the total low flow notch width was about 25 feet, having a depth of about 2.5 feet. The minimum, just so everybody knows, notch width for the target species will be 5 feet wide, which is governed by American shad. And also the minimum depth is 2.25 feet, which is also governed by American shad since they're the bigger fish there. So you can see that our minimum width is wider. So, can canoers, kayakers go through here? Sure. To put it into perspective, Bradford has notch widths that are about 10 feet. So these would be essentially double the width there. Now, I just showed at the concept level one big notch being 25 feet wide. We could break that up into two, maybe 10 and 15 feet or something like that. If if we find that that adds a little bit, or it's better for fish passage. Sometimes, I've had some reviewers agencies concerned, well, you have one lower flow notch, and you could have predator bird species that try and pick them off. But at 25 feet wide, that's a little bit. I think that's wide. That's pretty wide, so that may not be a
Can I
concern
interrupt
here.
you for one sec?
Yeah.
When you say the notch width, can you explain exactly what you mean by that? Is that like that little weir of how wide that little rock weir is? Or
The
how?
the notch width is it's a low flow notch. So what happens is during the lower flow conditions, flow will concentrate through that notch. So it won't overtop the entire boulder weir. It'll go through that notch itself. So that's basically allows us to get depth, meet our minimum flow depth requirements. So most every one of these boulder weirs that we've constructed in the past, they have a lower flow notch so that the fish can actually get through there during lower flow conditions. Right. I'll give you an example. Well, let's just say that the low flow was, and I'm totally making this up because it's larger here, but let's say it was 2 CFS, okay, which is not a lot of flow, but yet a fish needs to get through there during a lower flow passage. So let's say your river then is 50 feet wide and you're trying to pass 2 CFS across 50 feet. Well, guess what that flow depth's going to be? It might be a couple inches, right? So that's going to be an issue for fish to get through. So what happens is with these boulder weirs, you always have a low flow notch in there. That way you can take that flow and now that 2 CFS can it'll be forced through the notch itself so that now 2 CFS going through a 5 foot wide notch, it's going to be much deeper than 2 CFS trying to get over that entire 50 foot wide. So that's kind of the purpose of the low flow notch.
Okay.
So
Yeah. Notch, deeper channel, got it.
yeah, like during the higher flows, yeah, it's gonna go over the entire river width here, right? But during that lower flow condition, that flow will be concentrated. So that's the whole purpose really of a low flow notch. And again, this is not like just doing it for this project. That pretty much every boulder weir or step pool system that's designed, has these low flow notches. So again, this is just kind of a graphic that kind of supports what I was just saying. Like if you look at this top right corner, this is Bradford under low flow conditions. So see it, Stephanie, you can kind of see that flow is concentrated to that notch.
Yep.
So that's what happens. But yet during the higher flows, like in the top left, all the flow it's going across the entire boulder weir. And this bottom right is one that we did at Kenyon probably back in, I don't know, 2012. Same thing, flows going over the entire weir system here, but the notch is actually in this location. This is just a graphic essentially that just shows the profile during your 5%, your 95%, your 50% exceedance flows. So you can see one of the things that was kind of governing our design on upstream was this channel bottom comes up to essentially a high point. Just for reference, the existing dam is, if you can see my screen here, it's kind of hovering around this location. This is the existing dam location. So that the dam would be converted to a boulder, essentially a boulder weir in this spot. We'd keep the same alignment of it. That way, in case for historic purposes, we could say, yeah, the dam was here. This is the alignment of the dam, except that what you will see at the surface will be more a natural boulder weir formation, not the dam that exists today. But yeah, this going upstream, this is channel bottom was 28. So if we want to try and have at least 18 inches of flow going over that during our upstream migration season, then that elevation is 29 and a half. So that kind of dictated how many I would say boulder weirs that we had in here with step pools. And kind of to keep our energy dissipation factors less than 3.15, which is kind of like that maximum value you want to achieve. Essentially, our spacing was about 40 feet on center for both the boulder weirs upstream and downstream of the dam itself. The difference is that they were a little bit because of the narrower reduction in width. Sorry, downstream of the existing dam, we had to go a little bit deeper with the pools. The minimum pool depth you want to have is 4 feet, which you can see. So in the upstream pools, we achieve a 4 foot depth. For the downstream ones, we had to go about a foot deeper. So that keeps our energy dissipation factors at 3.15 or less. And again, energy dissipation factors are really just relate to the amount of turbulence that you're going to see in those pools. When things start to become a little bit too turbulent, then the fish kind of get confused, and that limits the effectiveness for passage. Again, now this was looking at, if you recall earlier, I was saying we're looking at now flows through Roosevelt Avenue Bridge, right? Because now the bridge kind of, again, functions to restrict flow a little bit as it comes upstream and down and moves downstream. It does restrict flows, so that generally results in a little bit quicker velocities through there. So we just have to make sure that when we take the dam out, the velocities don't get too significant where it could become a barrier. So that's where we kind of look at a little bit. We get a little bit more in depth than just saying, well, the burst speed is 6.25. Well, that's great, but because the burst speed they can maintain that for maybe a second or two to get through a notch, a low flow notch, but they can't maintain that burst speed, for instance, for 50 feet. It's just too much. So 50 feet here is about the width of the bridge. So they have to swim 50 feet through this, we'll say, increased velocity zone. So what we found by plugging in, for instance, the size of the fish, again, this comes somewhat from NOAA guidelines. And the distance, it kind of spits out based on the fish that we're selecting, which obviously we're selecting that herring here, that they can actually 97.5% of fish at this size can get through 1.4 meters per second current for, again, over that 50 feet, which is 15.24. So that translates to about 4.59 feet per second. So that's also, we just need to make sure that we're not exceeding those velocities underneath the bridge during the upstream migration season. And you can kind of see here in the bottom left, this is about what we were seeing with this full removal. So on the upstream side, it was 3.66 feet per second, perfect. 4.19 feet per second was also lower than the 4.59, so we should be good. I don't see the bridge being a velocity barrier. The other thing that we looked at is, okay, right, we're dropping the dam down. What does that do to water levels upstream of our project? So this is looking at flows during what we're referring to as the lower seasonal flow condition. So that's your aquatic base flow condition, which is kind of like the average flow through the river during August, September timeframe. So what you can just see from this profile is obviously the dam is here, and you can see that it impounds the flow, right? And you can see this straight line going all the way upstream through the Roosevelt Bridge, through the Conrail Bridge, and kind of converging into, I'd say, the natural river channel. I would say around the River Street area upstream. So what I did is I looked at, well, what is the depth under normal aquatic base flow conditions now, where the two profiles converge upstream at River Street, and it was about 1.5 feet in depth. So kind of I said, all right, well, let's look down, moving down towards the dam. You can kind of see now that now we get to a location of 1.29 feet in depth, 1.32 feet in depth. But then as you kind of move further downstream, all the depths are 1.5 feet and more. So again, just trying to say, river users are going through there, and obviously they're used to seeing whatever 2 feet of depth in this particular location. So now that's going to, obviously be reduced down to 1.32. But is this, I don't know, speaking, I guess, out loud, I mean, this flow depth is not super concerning, right? If it was 2 inches, I'd be like, that might be a problem, but 1.29 is not too bad. But again, you just kind of get a feel for how the water levels will drop upstream of the dam. And you can kind of see there being about a 5.24 foot reduction in head pond levels immediately upstream of the dam. And then we looked at 7Q10 flow conditions. And the reason we look at this is because, these flow conditions do happen. We know that we're experiencing climate change, and with climate change comes increased precipitation during, storm events, more frequent, larger storms. But at the same time, it also includes a little bit more drought periods. So, what we've seen on some projects in dealing with this is that these drought conditions do occur. I mean, I think in this particular river, I'm pretty sure there was one in September of maybe 2020, 2021, where the flows were really low. So it does happen. And I think this goes to sometimes when we're looking at our fish passage too, how does our fishway, whether it be structural, whether it be nature like, how does it fare under these 7Q10 conditions? Because again, this does happen a little bit more frequently than it used to. So you can kind of see during that sort of flow condition where, again, the dam backed up flow goes all the way up till about that point, again, where we converge into the natural river channel where you got 0.76, so 9 inches of depth occurring. As we kind of move downwards, you do get a pinch point here of about 5 inches in depth. Kicks back up a little bit to 102. Then you have 0.68 feet. So again, maybe 8 inches of flow depth, then maybe 10 inches as you get towards Roosevelt Avenue Bridge. A couple locations at that high point in the river channel just upstream of our fishway. The flow depth's going to maybe 6 inches and about 8 inches. So that just kind of the whole point of this is just to kind of give everybody a perspective of how water levels, we'd expect them to change during a dam removal scenario. And then this is kind of a really quick graphic. I have not QAQC this at all, but we kind of put this together looking at, again, the aquatic base flow. So during August, September, the boundaries in blue kind of show what it is under current conditions. And then what we'd expect to see that river level width be reduced to, for that full removal scenario with a fishway there. And I think that might be all I have. I mean, like I said, I don't want you guys to focus too much on this because we just started looking at the cost. We're in the process of doing that, but uh, what we need to do is I'm actually going to update all these alternatives because again, finding that we have more depth under Roosevelt Avenue Bridge, I think allows us to go. It changes the results of all these alternatives, right? Before we were kind of saying that, okay, if we dropped it 2.75 feet, then any more than that, then I felt Roosevelt Ave was going to become a velocity barrier for passage. But now I can say probably could drop it to 5 feet and be okay. So that's probably like, again, how these alternatives are going to rate. So before, that was actually alternative 1C. So 1C now is actually a 5 foot drop in the dam reduction, right? With a vertical slot fishway, and also alternative 2C would be just same thing, but with a nature like bypass channel. Now those are all viable alternatives, and obviously dropping the dam 5 feet results in less length for an actual structural fishway. So that also is going to be better for the project pricing. Alternative 4, which is this full dam removal with the Nature Lake Fishway, again, is probably going to be just I mean, throwing it out there, should be more expensive because I mean you kind of saw that the what we're looking to do out here. So I mean we're putting boulder weirs across, the river. So it's going to be a little bit more expensive. At the same time, is it going to have better passage efficiency? It may because I think it takes away some of the concern with attraction flow. Right, with the structural fishways, there's a lot more competing flow between what's going through the fishway and what's popping over the dam itself. So the fish can somewhat become confused. So locating the fishway entrance is more critical with a structural fishway. Here it's a full river width. The fish are they're gonna be able to get upstream. You know what I mean? They'll be able to find that. So that's obviously one of the pros with the alternative for full dam removal. But again, this table just kind of gives a rough cost range at this point. Have not QAQC'd any of this. It's not really at a level where I feel super comfortable with it, but just wanted to present kind of what we're seeing at this point.
Quick question with that, Sean. Alternative for the full dam removal, is that also removing the hydroelectric facility?
Yes.
Okay.
Yeah, but yeah, it essentially is. And let me just, I mean, I can probably pull this up in CAD here. So yeah, like you can kind of see this is where the facility was. So yeah, this green area indicates, would be green, more green space in the park area. Having potential portage in that alignment of the bypass channel itself. We'd have obviously passage into the park area, both upstream of where our portage starts to, go down. We also would have potentially another pedestrian crossing in this location where there's enough headroom to get over the portage and into the park area that, really not changing the grade too much in that current park area would be around 39 and a half or so. And you can kind of see the portage kind of comes down here to 32. So you got about 7 feet of headroom. So this could just be a pedestrian crossing in this location. And clearly, we may want to redo that timber overlook. Yeah, those are all included. But yeah, to answer your question, yes, that's running right through the old hydro facility. So this alternative would also include removal of the facility itself.
Is that driving some of that higher cost?
So it would be this, honestly, it's the same cost differential between these alternatives, 1 and 2. The only the only alternative that it does not include removing the hydropower facility is alternative 3. So, when you're comparing alternative 4 with 2 and 1 at this point in time, I would say that, yeah, all of them include taking out the hydropower facility.
Yeah, it's interesting that the more removal is cheaper for alternatives 1, 2, 3, but full removal is much more expensive.
Well, because it's because of the extent of what we're doing in the river channel.
Changing in the water and
Yeah,
adding the
I mean,
piers.
Tons of, like, we're moving the dam, but then putting in a bunch of mini dams. So it's just a lot of things.
Sean, was there any sound study on the weirs at Bradford? Because I know that that's going to be one thing that Mr. Yip is.
no, there hasn't.
Okay.
But that might be something, I don't know. And Nils, I mean, you had mentioned this the other day was, there might be apps you can download and we might be able to go to Bradford and actually try and record, some of the decibels at a system like that. But yeah, to my knowledge, there hasn't been any sort of sound studies at that location. So
We also have the Fishway at Kenyon.
say that again, Nils. Sorry.
Kenyon is
Yep.
another, yeah, similar system.
Right.
Yep.
I mean, we just did one in Marshfield too. But I probably would want that river system's a little bit smaller, so I probably would want one. I think Nils probably the Pawcatuck's maybe a little bit more, probably
Yeah,
better for this one. Probably Bradford is a similar size in river
yeah.
roughly.
My suspicion is that because you don't have water plunging over a 5 foot drop, but rather through these 9 inch, 1 foot increments, that it's going to be less. It's not going to be as much. It's going to be
Correct.
lighter. So I think that's kind of, yeah. I'll just say,
I agree, and I think that's the purpose for the matrix, right? There's
yeah,
pros and cons to each of
yeah,
these alternatives. So, I mean, keeping, for instance, whatever part of the dam up, like alternatives 1 and 2, yeah, I mean that you pro this the sound levels will probably be higher, right? Because you're really keeping that dam and you're still having flow going over, you're spilling over that at that one location. So my guess is that the decibels may be more like you're saying, Nils, on that one than, breaking that drop up into incremental drops of 9 inches or less.
This is Kate on the
Hmm.
computer, and I just wanted to say, having worked on Bradford when the dam was up, and then having shot the rapids at Bradford multiple times, I can say it's really loud. Like those
Yeah,
rock weirs
yeah.
really make a loud noise, especially in high water. So I didn't perceive any difference. Like it was not noticeably quieter with weirs in the river versus with the drop from the dam.
Yeah.
So
No, I agree. There's definitely some noise. I agree. It's just, I mean, you know what's going to happen is what that's. I don't know. I feel like we could say that, but at some point
yeah, it's one of those
we gotta
things
try and
where
quantify it somehow. So,
I think even if we quantify it, this is such an aesthetics issue, like a acoustic aesthetics issue. And I think um, if this ends up being a real sticking point for folks that appreciate the noise, especially if it's blocking, traffic noise and such, like hosting a field trip to Bradford because
hmm,
it's definitely gives rushing river rapids vibes. It's loud.
yeah,
I think that's a really good idea, Kate, is just, I mean, you could say it's X decibels or whatever, but I think that just bringing people to something and letting them hear it, they can be like, oh, okay, this is significant.
Stephanie, do you mind? So I'm gonna have to leave right at 10:30. So I wanted to just give folks like some, I've had a little more time than you all to
Sure.
think about this. And so I've, this is really great for us in the real team. And I guess I went from, I didn't think this was viable at all to this is totally viable. There's still a couple of points I want people to think about. So I talked to Sean about this. And it's just a consideration, maybe not one that's super major, but in one of his slides, he shows there are a couple of these spots where it gets pretty shallow. You know, it is what it is. That's at really low flow periods, but it is kind of below that like 5 foot threshold that he noted. So that's something to consider.
In terms of specifically fish passage, not thinking about recreation, right? Okay.
Yep. I think for
I mean, I was just gonna say, we've paddled in really low flow conditions, it is what it is, it happens.
Yeah.
Lots of different points on the river, it's just part of paddling.
Yeah, but certainly
For fish passage,
But I think it's somewhat mitigated, like that is low flow condition, which fish getting upstream might not be an issue, maybe as the migrating becomes an issue, but yeah, so that was one. I have no idea what the wetlands folks here at the EM are gonna think about this. So that's just a challenge that we'll have to work through if there's the ability to work through it. Sounds like I have no idea, what they'll think about that. The cost, I have to say, wasn't horrible, right? I mean, it's the most expensive, but not by like a lot. And so it is more though. You highlighted the removal of the facility, kind of bumping up the cost a little bit. There's another element that may or may not be needed that I talked about with Nils and Sean, and that is this armoring of the shoreline. And I had it as like this awful looking sort of witness it as it won't look like that. It'll be nice, they promised.
okay.
Still, it adds cost, but it might not be needed. So that would be a cost down there. But cost is a consideration.
and Jason, just to add, sorry, that I did include that after our meeting, so that 10 million there includes, a conservative guesstimate of stabilizing the banks upstream. So yeah, you're right. We may not need as much, but again, yeah, it's conservatively estimated right now.
John, you had one of your pictures of Bradford showed the opposite bank over by the mill where you used a soil filled stone armor practice.
Yeah, I
Yeah,
mean,
you
you
can
could,
kind of
it's
see
tough
it.
to see, sorry.
Yeah,
It's not
yeah.
the best photo, but
You have some more recent photos, that bank area with that stone armor that's exposed. It really kind of fills in and just becomes part of the landscape. I'll forward some pictures from, I don't know, later today or tomorrow when I get out there.
yeah, the idea is that we're not like throwing in like uh
Big revetment, yeah.
yeah, it's the idea is not to have this thing look like just a stone riprap slope. It's trying to, put sediment fill within there. Sometimes you can put live stakes too within there as well, but over time, like Nils said, you'll start to see vegetation kind of sprouting through, the sediment fill in there. So that's the intent here. But again, also trying to put something in that's going to remain stable and not erode away.
Yeah, yeah, so I appreciate that work, I had asked them, because I would want you guys to see like some lower number and then have it jump up. So as we start, put it in there as if we're gonna need it, it would be good news.
Right.
The concept of putting now a bunch of material in the river, I think that connects with what is concerned. It is what it is, but you're basically putting a lot of stuff in this one, this version. And the final one is just Mr. Year. So we talked about the sound thing. I had the same exact discussion with those guys. It's like, where we're going to be. I think right now I'm comfortable with saying there will still be noise, there'll still be sound curtain. That kind of sounds cool, so I'll use that too. But whether it will be exactly the same as now, that's where that idea of going to Bradford, thinking about it as like that being a mini version of what we're talking here. Be some empirical information we could gather to help us on that. But the other is, this is a big change, and so I'm gonna meet with him. I wasn't able to, as I told those guys, I was going to try and get with him between when we talked and today. That did not happen, but I will work on that. Hopefully by the next time this group meets, I will have met with him. And these guys kind of need a little more guidance, so they're not like moving 15 different businesses forward simultaneously, so they can get the work done. So I'll try and get that done as quickly as I can. I don't control his schedule, but I'll talk to him. I mean, he's been interested. I had the opportunity, as did Kevin, to sit with him at that symposium that we had, and he's pretty jazzed about this stuff. But this is a big shift that I did not talk about for him, so I just need to see where he's at on. Yeah.
Yeah, I think that's a good summary there. For DEM wetlands, what are the questions there exactly?
So I don't know, that's sort of not my gig, but I think it's more just my very conceptual. I think even though, and this is what twists people up, myself included, about this stuff, even if the wetlands, whatever they're seeing on wetlands, is there because of a man-made structure, it's still there and it's still an impact if you change it, even if you're going back to the natural state. So it's those types of things. I mean, what exactly they might flag, I don't know. I'm always surprised at how you sort of merge back with the existing river channel with these things. It seems like such a giant, I would think this would impact all the way up the river, but it really doesn't. It has a limit to it. But yeah, I really don't know what they may or may not flag. Maybe it's built up enough around it that it won't be an issue. I really don't. It's just something I've never really seen it not be an issue.
I think the other element of doing a full removal is grant availability.
Yes,
and be much more competitive for grants to say we're doing a full removal versus we're adding a nature lake fishway. So even with that cost difference, um, I would worry as much.
totally fair, yep. At
Well,
least
I would say
complete.
the full removal includes a nature lake fishway.
Yeah, that's true. I guess so. Is there a difference between like rock ramp fishway? I know you'd mentioned at one point versus a nature lake fishway, or is that basically the same?
I
I
think that's
think,
basically the same.
It's defined in the guideline U.S. Fish and Wildlife guidelines. It's pretty much the same, as long as you're using natural materials to construct it. Um, it's
yeah,
considered a nature like fishway, whether it's, they use the term sometimes rough in channels. In this case, we're using more of a step pool system, both nature like fishways.
And I can't speak to what DEM wetlands are going to be looking for in this specific project, but for other dam removal projects that I reviewed when I was at freshwater wetlands, we were concerned about things like making sure the project won't impact flooding downstream or upstream. So making sure that the floodplain impacts are balanced. Looking at the sediment management plan. So if sediment is going to be allowed to move downstream during construction, is there a specific science-based reason for that? Or if there are sediments, DEM in general wants to make sure that the limit of disturbance in the river stays pretty tight and doesn't sort of expand beyond the limits of disturbance that we'd show on our site plans. They're going to be looking for rare species in the river, so like freshwater mussels. Maybe there's rare dragonflies that might be breeding out here. Um, it's usually mussels and dragonflies are the two sort of species that pop up. So making sure that if there are, and it's not a deal breaker. So if there are mussels in the river, we collect them and then put them back when we're done, right? So, um, and then in terms of functions and values for wetlands overall, this is a super urbanized system. Like there's very little buffer here. It's in the lower Blackstone River. Blackstone River is already fairly polluted. I don't think that DEM wetlands is going to have as many habitat concerns as they did for Bradford. I mean, Bradford is a totally different, like the Pawcatuck is a totally different river from the Blackstone River, has a lot more wildlife habitat and is generally cleaner. So I think the main things are going to be the in-water avoiding and minimizing impacts, so freshwater mussels and that kind of stuff, maintaining the sediment. And then engineering, like engineering is really going to want to look at those floodplain impacts and make sure that any fill added from putting in new stone is sort of balanced with cuts, all that stuff. So,
hmm Yeah, and that's one of the things too I compared as well, like just making sure that we're upstream of the project, we're not increasing flood elevations. I mean, clearly we're not. What I found is the 500 year is pretty much the exact same because the bridge is a restriction. Um, so anywhere from upstream of the dam all the way up. 500 year doesn't change. The 100 year drops a little bit. Obviously, the 50 year drops more. The 10 year drops more, which is good. The only locations that I saw, like for instance, increases in flood elevations were just downstream of the existing dam, where we're putting in a few boulder weirs to start lifting the river up. So, that was really the only location that it occurs. You do have a structure. You know, that's already in or bordering the floodplain. So, what we need is obviously the property owner to be okay with that. Like generally, anytime you're proposing an increase anywhere, you need a sign off from that property owner. So they would have to be on board with that. So we would just need to make sure that if we are increasing the elevation in just a couple of those pools just downstream of the dam, that they're not creating more an adverse condition to that structure. So yeah,
Sean,
it just adds to that.
the floodplain downstream in that area, does it exceed the banks into that parking
Yes,
area?
it does. Yes,
Yeah.
it does.
So
Yeah.
do you have an idea of the magnitude? Are we talking like hundredths of a foot? Are we talking more tenths of a foot?
So yeah, I'm not sharing my screen, am I?
You
you
are.
are.
Oh, I am? Oh, okay. All right. Sorry. Okay. I don't know why am I Zoom, I can't even see that I'm sharing it. But so anyway, this is let me just try and it's kind of the skew of how this looks. It's a little
Oops,
funky.
I apologize. I have
Thank you.
to
You're good.
leave.
Yeah. Jason, were
Okay.
you all set? Because I can get into this after you leave. I didn't.
Yeah, yeah,
Okay. Okay.
yeah, thank you so much. And, you may also, I don't know, Matt, if you had a chance to talk with the rest of the Fish and Wildlife team, but you might bring that up.
Yeah, we're gonna see next week.
Thanks, everybody.
I can't totally speak for everybody, but I think that the other folks who are not here today would also be very excited about this.
Yeah, I'll agree.
I will pass it on. Thanks, Jason.
Thank you. Bye, guys.
All right. Sorry, I'm trying to kind of improve the confusion sometimes with this. So let me just add one more option. And all right. This is a little bit better. So you can kind of see where the increase. This is the 100-year storm specifically. So Nils, you can kind of see this structure
Mhm.
here is where the existing dam is. So you
Yep.
can kind of see where we lift off the existing profile for the 100-year. So that's those pools that are downstream. So with that, I'll take probably the worst case increase. I'm just going to pick this one. So that's elevation 4165. And then you have, if I can click on it, 40.73. So it's about zero point 0.9 feet. So it's close to a foot increase. Again, just downstream of the existing dam and those two pools is probably at most. Anything upstream of that is a reduction. Like you can see where we're below. And just so you see that here's the 500-year flow. See it? So we're actually below, and then we pop up in that one location. But again, for FEMA purposes, they just look at the 100-year. But I just wanted to show everybody. So there's the reductions upstream for the 50-year. And as I go to the 10-year, you can see even more of a reduction. But yeah, going to that 100-year, Nils, this is the case. So immediately downstream of the dam, you can see that the existing elevation, we'll just pick this one here. So the existing elevation was at 40.7, and this is 41 point, we'll say 7. So what that looks like in CAD is if we go again, the existing dam is here. So that pool is like right in this area. You can see the parking lot's at 38.7, 39-ish.
Mhm.
So
Mhm.
currently, you have at least, a couple feet of flow in there. And you can see the building as you get up to the building, you can see a spot of 39.4. So right now I have that floodplain of here's 40.4. So basically that floodplain is coming up around this area currently. And you can see how it pretty much runs. The structure is within that based on what I'm seeing.
Sean, in order to avoid that, you'd need to move the whole fishway upstream.
I would, in order to avoid
Or,
that, correct.
or you could
Correct.
cut the channel bank, remove more bedrock to increase depths downstream.
I mean, yeah, you'd have to look at where you want to do that. We probably don't want to start cutting into to this side of the river where the building is. Maybe there's potential on this side to start dropping, some of this cut through ledge that's kind of
Mhm.
sticking out. Yeah, but
Mhm.
you're right. We could potentially kick it upstream to avoid that.
But
So
that's going to
we
increase the cost because you're going to have more excavation upstream,
well,
more
it,
grading.
it it increases the cost, yeah, but to answer your question, like right now, where this ends is a nice spot because if you kind of imagine where this boulder where it ties in, it basically
Right.
ties into that
Yeah.
existing upper limit of that raceway.
Yep.
So if we go a little bit upstream of that, yeah, let's just say we were to take the three weirs and put them upstream. Yeah, I mean, you can see the river is obviously wider.
Mhm.
We'd have longer weirs, so it may increase the cost marginally. I'm not saying that that's make or break at all. I'm
Mhm.
just,
Mhm.
yeah, we definitely could do that. So that's something that we would have to look into if we're all like, hey, this is the alternative we want, then as part of the next phase, we would look at, trying to wipe out any sort of floodplain increases. So that may mean, yeah, we take these three lower weirs and we push them upstream.
I think that would be wise. I think that might be like a significant red flag for DEM.
I I agree. I agree with you, and kind of running through that and seeing that, I think that that makes a lot of sense, quite honestly. And yeah, I think it might be good for a few reasons doing that.
Any other questions?
So it sounds like there was the question about floodplain, and we maybe have a solution for that. The rare species and habitat in general might have a good answer for that. Sediment management plan is still a little bit TBD. It sounds like looking more at how much you have to reinforce that bank versus how much is fines and would need to move.
Mhm.
And then the last one was the limit. Kate, you mentioned having the limit of disturbance be as small as possible. And it seems like doing this kind of project inherently has a relatively large footprint that's all directly in the river.
Yeah.
So
Well, it's
is
not necessarily as small as possible. It needs to be the minimum necessary to improve to get the project done.
okay.
So, and then there's also some like weird nebulous thoughts around avoiding and minimizing. I'm not too worried about the larger limit of disturbance here
Okay.
because we're working in a disturbed area.
Yeah.
Yeah, I agree. The sediment issue is important because I mean, there's definitely a lot of hot sediment along the river. So,
But it's pretty
that's
ubiquitous. Like if you
Right.
go up to Valley Falls and you go down
yeah.
to Slater Mill Main Street, there's nothing that really screams out in any of the sediment that we've seen. It's been distributed so over many decades that um, you're not really degrading the quality of the river if it does move downstream.
No,
Um,
because I think we found Nils I mean, yeah, the contamination levels kind of
yeah.
progressively get greater the further downstream you go, which
Mhm.
to me makes sense. But yeah, 'cause I think we had that highlighted in one of our slides as well in terms of sediment. I'm just trying to see if I can
I
pop
think
it
the
up.
other point to maybe consider that we'll have to just reflect in this is these bank areas that are going to be exposed, and you have these property owners upstream.
Mhm.
Right now, their property runs up to the edge of the river, and now the edge of the river is going to move towards the center, and that newly exposed channel bed will become property that may have characteristics, and I recall hearing concerns or questions in the 10 Mile River. And I don't know, Kate, were you involved in any of that or have any insight
Yeah, I
from
was
your
involved with the 10 Mile River project. The kind of a long answer is like we're recognizing this as an emerging issue for Rhode Island, and Save the Bay, the Narragansett Bay Estuary Program, and Roger Williams University are looking into more of the whole like how do property lines change
Mhm,
after a dam removal, and more of like the legal questions and not
mhm,
like the environmental restoration questions.
mhm,
Because you're absolutely right. When somebody lives next to a project like this, they're going to be like, well, my property line goes to the edge of the river. The edge of the river is moving. Does that mean my property line's moving? So
mhm,
having legal scholars look at those questions and look at the case law, we won't be able to definitely say, no, you're good, but we'll be able to give some information to folks and
mhm.
have them, you know, understand what's happened in other specific cases.
Okay. Is that work ongoing, or do you think that it'll kind of come out with some guidelines or something
Yeah,
that
so the work's just getting started. It's a summer project. I heard we're hoping to get a final project by mid-September. And then I think so the final product from Roger Williams is going to be a white paper. And then our intention is to take that white paper and create like a frequently asked questions document that we can
great,
use not just here, but at dam removals all across Rhode Island.
great.
Um, Mills, you might, I'm not sure if you were at this Hudson Pond Dam meeting up on the Pawcatuck, but my recollection from we had some similar questions at that meeting, and my recollection from that, and Sean might remember when he gets back, is that some of these things vary across the state. It's not the same statewide. So I'm not, I think that'll hopefully be something that comes out in this study that Kate is referencing. But It's just something interesting to think about when you're thinking about applying knowledge from one project to another, right? Is that
Yeah, I mean,
it that
this
was
def
unexpected to me, but
yeah,
seems to be the case.
well, this
Yeah.
definitely came up in Potter Hill, and you can
Okay.
imagine there are some, property owners who enjoy the flat water upstream of Potter Hill and west on both
Hmm.
sides of the river. So you're talking about 20 to 30 properties owners who enjoy deep water, deep 9, 8 feet, party boat type, enjoyment. And they talk about, or the way, again, rightly or wrongly, based upon what this white paper says, is that the property, you'd have to do deeds and research if their property extends to the center of the river. Well, that
Hmm.
means they own the land underneath underneath the water, but they
Hmm.
can't do anything with that land because the state has control over the water column itself. So when that water column moves, well, the property line still runs to the center, but now there's no water on their exposed land. And so again, it's like, well, you own that land. It was just underwater. Now you still own that land and now it's exposed. You can do with that land anything that you can do within the permitting, or regulatory requirements. Like if they have turf grass going right up to the edge of the river, can they push the turf grass right out to the new edge of the river?
Hmm.
Well, no, you really can't, but is DM going to enforce it? It's
Yeah.
kind of like, you know, so that's what their concern was, is invasives coming in on that
Yeah.
newly exposed bank area. We had monitoring and
Yep.
mitigation plans developed, adaptive management plans, and what they really wanted to know is their view shed going to change, and are they still going to see the water through their kitchen window, looking out the back?
Right.
And we said,
Yeah.
well, we can't tell you that you can cut anything that grows on that newly exposed riverbank, but you know,
Yeah. Yeah.
Just to point out a possible complexity to this. You showed on your map, Sean, where the wetlands would be moving. A parcel of that is technically in Massachusetts, where Attleboro is.
Hmm.
So we're not just talking about Rhode Island, but also Massachusetts now.
Yeah, I think up in this, yeah, you can see it here. There's that mass line. You can kind of.
You're not sharing anymore now.
Oh, Jesus. All right. Sorry. I'm gonna get it right one day. All right. Maybe now?
Not yet.
Okay.
Oh,
There you go.
Oh, all right. Here we go. Yeah. So you can kind of see what you were just talking about. So this is that Conrail bridge down on the bottom here. So there's the mass borderline, at least in this location that I was seeing coming pretty close to the river's edge. Is this what you're referring to up here?
yeah, that's known as Granite Park. If John Marsland was here, that used to
Okay.
actually be a public park that's now overgrown. But yeah, so I know that that parcel is owned by the Pawtucket Water Supply. Um, but I don't know. But it's just such a weird boundary. Like I don't know if they own that little chunk or whatever. But yeah,
Yeah.
that's a fun spot.
Okay. Yeah. Let me see if I can.
Yeah, it's not only 2 states, it's 3 towns.
Yeah.
Let's see if I can pull it up here, Central Falls, at least to see what they're
Yeah,
showing.
I'm on the same website. That's fun.
Okay, all right, yeah.
They show the Attleboro boundary like to the
Oh yeah,
line.
right about here, right? Yeah, I see it. Yeah,
Yeah.
correct. Yeah.
Yeah, and that's a good question of just having the actual deeds, because we've looked at a few parcels that no town really claims on their GIS, and it's just this weird no man's land.
Hmm.
So that happens a lot.
Yeah, that's another piece of the puzzle in there.
So we've got about 10 minutes left. I think the summary of everything this morning is this is exciting that there's this opportunity to potentially explore full removal, that it might be viable after all.
Hmm.
So
I
yeah,
mean, yeah, I mean, I think that's fair. Or worst case, I mean, a greater removal of the dam. Like if it is ultimately decided to go structural, I think you can go, lower than what we were initially thinking. So I think that's good news on both accounts. Clearly, I think a nature like Fishway is probably the best when you're just looking at fish passage.
Yeah.
So
Okay. So let us know, any updates or questions on that. And any particular other concerns that come up, and when and if it makes sense to do something like a tour of the Bradford site and bring Mr. Yip there. We can keep having that conversation. For the other things that we typically go over in these meetings, and again, apologies, I didn't actually send an agenda, but is there any update to the Main Street Slater permitting?
No, the public comment period for CRMC ended on May 10th, and I checked in with Tracy Sylvia just to see if there were any questions or comments that came in that would warrant us to clarify or address or, have a hearing over, and I haven't heard back from her.
Okay.
So I did get an email from us Army Corps as well. And it's a pretty straightforward question about the linear feet of impacts on the Seekonk and the on the Blackstone River, and then respectively. And then there was also DOT questions and comments about the traffic management, pedestrian, diversion, if you will, around Main Street. And we just addressed those. We're very straightforward.
yeah, they don't matter.
Yeah, so we're expecting that DOT will continue its review. I know that CRMC and Army Corps are kind of working through the Section 106 consultations with SHPO. So we'll hopefully get a better idea on where those things stand, and then we can, keep things moving here and hopefully get the permits, in the next few months.
Okay. And then was there ever a lead federal agency that was identified?
Nope, there's no lead federal agency, so Army Corps would be administering this process itself.
That's just sort of the de facto.
Yeah. Yep.
Okay.
Yep.
Great. Okay. Thank you. I assume we have no update on what's going on with PRA and the downtown gateway redevelopment.
No, we haven't heard, and we haven't, quite honestly, I haven't inquired with Jason Pizzulo or anybody else with the city relative to where that stands. They hold their cards pretty close to their chest. So I don't have an update.
Yeah. I know when we've worked with Kyle from Pawtucket and asked about it, we've just heard that they're doing a lot more meetings than they anticipated with the proposed developer or developers, and nothing's public yet. So,
yep.
January, June, same thing, here back. Were there any other updates on other sort of dam projects or hydro projects that we want to mention? Okay, I assume there are also no updates on funding awards like NOAA, WERDA, CBS. Okay, this is very quick. Oops. For events outreach, thank you to many of you who came to our Fish Passage parade on Saturday. We were sold out of kayaks and explorer seats, so it was a really successful event. It was gorgeous weather. It's always a fun little quirky thing where we have a little bit of everything from like the giant ranger with a fish head coming to Chip from Rhode Island Football Club to indigenous flute players and face painting and kayaking. It's like this weird mishmash of things, but it's always a good time. So thank you. And we have so much really cool artwork as well that we got from different students from Worcester Tech High School and Worcester East Middle School. So nice to collect that. There was a question, I guess, Jason had talked to John Marsland, wondering if DEM wanted to stock Valley Falls Marsh with herring. I guess they did a number of years ago. And if they wanted to sort of next year at the fish parade ceremoniously release some of those herring. I don't know if you've heard any updates on that.
Yeah, so you're talking just like releasing a bucket of herring, right?
I don't know. I mean, I think that that's what John.
So I know John last CAC meeting, I think he was just talking in general about stocking Blackstone,
I think that he was talking generally about stocking,
but then on
but
Saturday.
also doing this like bucket release at the fish parade.
So it's not gonna be viable really to stock in general. Because while there's still active hydro,
Okay,
we just don't wanna risk mortality,
fair.
but it could be. Potential for like a small ceremony stocking at the parade.
And watch them get sucked up.
I know.
But
Okay,
it would be challenging given the timing. I don't want to run winding down. Well,
Yeah, it's more of us just doing something to feel good about ourselves instead of actually
keeping them on.
okay,
So challenge.
okay, thank you. I'll put that in there. Was there anything else that folks wanted to share for those who did go to that Tidewater symposium?
It was just, I enjoyed it. It seemed like the organizers had a plan of talking a lot about development. They talked a lot about activating the riverside. However, the entire audience was more interested in the river itself and not like where you're gonna put a splash pad. So I found that really just good to hear, honestly. Was that a lot of people focused on the river itself. The riverbanks, even though the organizers weren't. But Kate, if you had any other takeaways.
Yeah, so I thought it was a real smart move for the folks that care about the river to sprinkle ourselves amongst the tables, so we could hear from folks that we don't normally hear from and get a different perspective. I sat at a table with some structural engineers and also leadership from the Boys and Girls Club. And one of the things that kept coming up, the political speakers were like, oh yeah, it's a done deal across the river. See all those trees, they're going to get obliterated. And everybody at my table, not just the environmentalists, were like, well, that's a shame. Like, I would really like seeing those trees across the river. And folks were like, well, what about the Apex building? Can they do that development there? So I know that's not how development works, but at least from folks who are development minded enough to come to an event like this, they see the value of redevelopment and not just cutting down every stitch of green on the river. So that was a main takeaway.
Also, it was opened by AI Mark Twain.
Oh God.
Which was tough.
Great.
Mark Twain's well known for his visits to Rhode Island.
We're close to Connecticut. He was in Connecticut. Okay, thank you for that. We also went to, some of us were presenting at RIFMA. I saw Sean and Nils there as well, Rhode Island Flood Management Conference, which was really good. We presented on our Kitty Carp Restored Plan and people did have questions, which is not fish passage related, but people did have questions about fish passage. So we got to talk about that a little bit and hopefully get some more interest around the project. There was also a mention last time that there was an annual meeting for Atlantic State Fisheries Commission in Newport in November, and whether the collaborative would maybe want to attend or present or table. And Jason said that he would follow up. Keep that on his plate.
Okay.
He can. Okay, yeah. So Jason will follow up with more details to see how we want to participate. So. Okay, and then I think that's it on our agenda. So just a reminder for in-person, which is really just me, Kevin, today. But if anyone does come in person, you're supposed to like check in downstairs now before you go up.
One thing to note about next meeting, there is not a World Cup game on that day, but there's one the day before and one the day after. So getting to here might be an issue for some folks, and when I say some folks, I mean me.
Yeah.
So I will be virtually at least.
That's totally fine. Will it be worse here?
It's tough to say.
Okay. Well, if we want to change it to virtual only, we definitely can.
Yeah, might be a decent, I'm planning on not coming to Rhode Island for at least 4 weeks.
That's fine, we can do virtual only, for the next meeting, in light of. Great, all right, well, I will actually send some notes, and follow up, and we'll get you an agenda for next time. Nils and Sean, do you anticipate wanting to present at the next meeting again with updates? You're on mute,
When will that be?
April.
The reason I'm asking is because I have a vacation scheduled
Sure,
starting the 20th.
okay, it says June 18th is our next meeting.
So I should be here for that. I know it's generally always frantic before vacation because we have like 3 or 4 June 30th deadlines. So yeah, I'll be here. So yeah,
Okay.
I think we could, right, Nils? I mean, you tell me. I think we could probably give an update at that point. Oh, you're on mute.
Yeah, we're gonna obviously keep working on this, so whatever, whatever update we have, we'll share. I mean, I do
Okay, great.
have a draft report that we can, you know, at least preview, so.
Okay, that's
Yeah.
no problem. Okay, great. Well, thank you, everybody. We'll see you virtually for our next meeting on June 18th.
All right. Thank you, everyone.
Thanks,
All right.
guys.
All
Take
right.
care, everyone.